So this is our topic, or our final topic, FET switching circuits. Previously, the FET circuits that we have encountered are made up of JFETs. Okay? So JFETs man tutunan class ba? So JFETs shine brighter when used as amplifier. Okay? Amplifier. Even kay boilostad, if mabasa kang boilostad, depletion MOSFETs work in the same way as JFETs and could be also be used as amplifiers. Now, JFETs and even D MOSFETs gapon, nako dili. D MOSFET or depletion MOSFET. Okay? So, parehas sila because ilang equation for ID is the same. Okay? But for switching circuits, especially this afternoon, mas magamit ang E-MOSFET. Okay? Or enhancement type MOSFET. So, E-MOSFET. Sometimes MOSFETs are shorthanded as MOS. MOS lang. So, kung makadugta na nga term, MOS, definitely MOSFET iyang gibutwa sa butana. Okay? So, again, switching circuits particularly use E-MOSFETs or enhancement MOSFETs. Especially switching circuits that are found in integrated circuits. Digital and integrated circuits. Or ICs. I think we're familiar with this one, ICs. So, E-MOSFET. So, for the E-MOSFET, we have two flavors for that one. In the same way sa other transistors that I discussed before, whether JFET or BJT. We have N-channel E-MOSFET and P-channel E-MOSFET. So, ang E-MOSFET comes in two flavors. Ay N-channel MOS and P-channel MOS. Or NMOS and PMOS. Now, the same sa before class lang. Difference sa ginanin duha is ilang majority carrier. Majority carrier for NMOSFETs or NMOS kay electrons, and ang majority carrier for PMOS or P-channel MOSFET kay holes. So, mo lang difference. Of course, that's make their mechanism slightly different. But at least now, we know. Kung takuan nila ang symbol na pakita sa nako today. Ilang electrical symbol. Diba? Okay. Ang arrow sa PMOS is pagawas. Yan sa NMOS pasulod. So, muni siya, muni ilang mga schematic symbols. Ako sa memorize na. So, sa NMOS ni sa silong. Kani, Ano siya NMOS? PMOS sa taas. Okay, paani. And then, ana. Alright. So, if we pumasayop, ang schematic symbol sa NMOS is yung ani. Dire, connected dyan sa source. So, naitulo. No, natulo ka marag separate nga lines here. Pero later, sige lang, di na niya mag-matter kay natay shorthand ani. Yung arrow is pasulod. Okay. So, I think mo ni siyang atong NMOS. Nadili ang source, nadili ang drain, and gate. And the same lagi po ang schematic for the PMOS. Except ang arrow is pagawas. Source gyapon ni dire, drain, and gate. Okay? Now, I hope we understand nga medyo na challenge even sa pag-drawing sa schematic symbol, no? So, natay shorthand sa symbols para madali ta. Okay? Unlike amplifier circuits nga mostly pwede lang ta maka-analyze og isa lang ka device or ang isa ka amplifiers or ang isa ka amplifier circuit could be composed of possible isa lang ka transistor na device. Switching circuits could be composed of multiple MOSes. So hassle if kaninga schematic at kaninga notation ang gamiton. So natay shortcut nga gamiton. For the NMOS, we'll use this notation. No? So, dali lang ni siya. Instead of this one, or these two, for the NMOS, we'll use this notation. No. Ano lang. Okay? So, source, drain, gate. Ang PMOS, the same lagi hapon. But na ay bubble here. Ano? Source, drain, gate. So, may itong NMOS. PMOS. Ano? So, ang paladali na ito matimanan, ang difference lang yun nila is ang PMOS na i-bubble here. Ay bubble. So, bubble denotes inversion. Paglalagay kayo ni. So, the bubble denotes inversion. Inversion of what? Inverse operation ang PMOS sa NMOS. Ano lang, no? So, i-invert niya whatever is the operation sa NMOS. So, that's what the schematic symbol bubble is for. So, more on that later and more on that soon. So again, MOSFETs are used for switching circuits. So for digital switching circuits, so does that mean na analog? Yes, na analog. Pero di na kita mo go deeper ato kay ipaka-understand sa operation sa digital switching. Pala lang analog. No? Siguro mag-matter lang kung unsang i-input na signal. So ang difference of digital switching and analog switching is not the circuit particularly, but the type of signal na i-feed. So for analog switching using MOSFET, ang input signal is analog. Of course, ang output is analog yapon. So for the digital, ang input is digital signals, no? So, regarding that one, mag-create og somehow abstraction, no? Or shorthand, no? A tool to help us analyzing digital switching. Kaya dagan magklase gud nga when you say switching, it will be it is transitioning from one state to another, no? So mo lang gina ang basic idea sa switching. It's transitioning from one state to another. Or transition between states. So what do we mean when we say state? The most common two states that we are familiar with are on and off, no? On, off, on. But actually, dagan pa man classic states. Pero ang common nila is duha ra gyud, no? Duha ka states, transition from one state to another and from the previous state to the next state. So again, it could be on or off. So tang lang to diri siguro og kuan. Table. More common kay on o off. Okay? Pwede gapon positive 5 volts and 0 volts. Pwede na, no? So transition siya from a positive 5 volts to 0 volts. Pwede gapon from a positive to negative. Or instead butang na itong specific nga positive 5, let's put positive VDD and negative VDD. Pwede na. Pwede source to ground. Source or ground. No? Yan na. Less common for capacitors, transition siya from a charged state to discharging state. Discharge. Pwede. If magamit ang magnetic na devices, pwede transition siya from north and south and vice versa. So, daga klase, no? So, ato na siyang i-combine. All of this, ato i-denote as logic 1. Okay? So, when I say, or when we say 1, it's probable na both pasabutan na is the terminal could be connected to a source. Or if source siya, gi-on na tong switch. No? Or if capacitor, na charge. So that's the logic 1. And I'm sure, kabalo siguro mo sa name sa other one, it's logic 0. So ang logic 0 could be off or 0 volts or negative source, negative VDD or ground. Actually, pala naman yun. Pala na yung 0 volts or ground, di ba? Or if capacitor siya gi-discharge or if magnet siya na nasa south. So any of these could be either a logic 1 or logic 0. No? So example lang, natay source here. Okay? So ang atong switch is naka-off, ba? So that's logic 0. And ang light bulb naka-off pod. So logic 0 gyapon siya. No? The same circuit, ato i-turn on ang switch. So ang light bulb mo siga. Ang kuluran pala. Char. Na. So, ang switch is na-on man siya. That's logic 1. And ang light bulb turn on is also logic 1. Okay. So, in this case, the switch transition from an off to an on, allowing the light bulb to also transition from an off to an on state. Okay? So, so far, sige ka na lang sa. So, ito na na-define unsa ang logic 1 and logic 0. So, how does that relate to our MOSFET or E-MOSFET? Or in this case, our NMOS and PMOS. Before I go further, so NMOS and PMOS are used simultaneously, no, or used in tandem or used together. So NMOS is used together with PMOS. And kaninga particular device is collectively we call CMOS, no? CMOS. So I mean CMOS is complementary MOS, no? Complementary metal oxide semiconductor. So CMOS and NMOS together, CMOS and PMOS together are, NMOS and PMOS together are collectively called as CMOS. So again, how does the idea of logic 1 and logic 0 relate to PMOS and NMOS? So this is what happens. Start una sa NMOS. So for the NMOS, sa yung schematic, ana, diba? Okay. So what would happen if we apply an on to the gate? No? So we apply to the gate a 1. So ang atong NMOS is ma-on siya. No? So it's as if inside bitaw the NMOS is a yung equivalent ani equivalent lang niya nga circuit, just to simplify things. Switch. Naman siya switch. Okay. So if we apply a logic 1 to the gate, it closes the switch. So ma-on ang ma-short. Ma-short ang switch in this case. So my tabo is, if apply ng logic 1 sa gate, so shorted ang gate. Okay. If we apply a logic 0, dito siguro itong kuan. Ay, blue siguro itong 1. If we apply a logic 0 to the gate, ang switch inside the equivalent switch inside the NMOS will open. Okay. Try to memorize this one. Or I may at least yung operation i-memorize na to. Na basta NMOS gani class, basta NMOS, if we apply a logic 1 to the gate, ma-short siya. If we apply a logic 0 to the gate, ma-open. And I guess makuha ninyo yung idea sa PMOS. Because the PMOS is an inverse operation sa atong NMOS. if we apply a logic 1 to the gate, open circuit siya. No? And bali na dayon if mag-apply ta og logic 0 sa gate, ma-short ang switch inside the MOS. Okay? Pwede gate na magamit og word nga on ug off. Basta short kay on na, di ba? Na switch. And basta open, off na switch. So, dahil siya timanan. Basta NMOS, ano lang ha? Basta NMOS gani, kay NMOS wala man siya bubble here. Ang NMOS, kung saan i-apply sa gate, may tabo sa switch. Kuha. Sa PMOS, kung saan i-apply sa switch, sa gate, sorry. Sa PMOS, kung saan i-apply sa gate, i-inverse niya. No? Meaning, if nag-apply ta og 5 volts sa gate, meaning na-apply ta og logic 1 sa gate, ma-off ang PMOS. If nag-apply tag logic 0 sa gate, or if i-connect na to sa ground ang gate, na on. No? So, inverse siya. So, di pa siguro di kayo na ma-appreciate now. Basta so far, kuhan lang yun, no? Memorize lang sa good. Ang ilang operation, simple naman. Malaman to ang atong need or requirement. So then after this one, we'll try to analyze one of the simplest circuits that we could construct using CMOS. So before I go further, any questions? So if there are none, sige, let's continue with our first CMOS circuit.
Madunggan ni mo di ilang sabak. Madunggan ni mo ilang sabak. Ilang sabak. Madunggan ba ilang sabak? Sabak.
Okay? Later na ang name, kung makuha na nato iyang operation. Okay? So, sa image nga akong gigamit, yung gigamit nga schematic is the conventional one. No? Pwede ba nato ni i-redraw para kuan? Sige, redraw na to ha. So, VDD could be drawn as such, or pwede gyapon ingani. No? As simple as that one. No? So, muna ang VDD. Directly connected sa VDD ang, saan eh? PMOS and MOS. This one. Paggawas
PMOS,
ng
sir?
arrow. PMOS, no? So, sakto. PMOS to siya. So, ipagawas mo ng arrow niya. So, connected sa VDD is PMOS. Drain sa PMOS. Ana. No? Hiwi man yun. Kagat lang. Mm-hmm. Okay na siguro na. And connect sa iyaha sa source sa PMOS is ang drain sa NMOS. NMOS man eh. No? And connected siya sa ground. So, nadiri ang input. Nadiri ang output. Okay. So, erase na natin eh. Yung isa. So, itong gilid law using our shorthand symbols para mas dali na ito ma-analyze. Well, wala man siya contribution good sa pag-analyze. Pero later, kung mag-drawing na tagdaghan kayo yung CMOS, no? Medyo tedious tong isang symbol. So, sa itong mga convention, basta VDD is 1, basta ground is 0, right? So, VDD is 1, ground is 0. Okay. So, we'll try to determine what is our output if our input is either A1 or 0. No? So, doon lang na itong possible inputs, 1 or 0 ra. So, doon lang po ito possible output. So, atong i-map, no? I think that's the proper term. We'll map our outputs based on given inputs using a truth table. So, if this is the first time that you've heard of this term, a truth table represents the input-output relationship of any digital circuit. So, sa digital circuits na gini, particularly ma-apply digital circuits. Again, a truth table maps the relationship, no? Relationship between input and output of digital circuits. So, okay naman siya in and out, no? Kay man kayo complicated. So, a truth table looks like this, no? Very simple lang, malalagi siya columns of rows, no? Input, output. Yan lang, no? And because dual lang mong klase ato input, dual lang itong row. So, it's possible that our input is either a 0 or a 1. Lang. So, ang atong output, dual po possibilities. Either 0 or 1 or 1 or 0. No, naraan na po. Okay. So, this will be its truth table. Kung mabuta tawag higher digital circuits class, this is what we call a logical function. A digital circuit, the function of the circuit could be called a logical function. So there are many ways to illustrate a logical function. One is using a circuit, such as this one. Another is using a truth table, such as this one. Another way is using a Boolean equation. Pero karon sa electronics 1 or even sa electronics 2, pa siguro gid ta magamit ang Boolean equation. That would be next year sa ECE 18, Logic Circuits, Boolean equations. Balik na dili. So again, possible na to, nga inputs only 0 and 1. So we'll start with 0. So what if we'll apply a 0 sa input? 0 sa input. So mo travel siya, mo split na siya, isa padlong dire, o isa padlong dito. Correct? So if 0 ang input, 0 po na siya dire, o 0 po na siya diha. So what would happen to the PMOS if logic 0?
Open, sir.
PMOS, logic 0, short.
Short,
PMOS
sir.
man. Diba? No? So it's always the opposite. Okay? Okay, with PMOS. Okay? So basta PMOS, balihon niya. So kung shortcut ni, dito na ni butang 1 dire sa NMOS, 0 is 0. Kaya ito sa illustrate, no? What's happening. So here, because PMOS is short at 0, so ato sa ning i-replace og circuit, no? So short, okay? Short na siya. NMOS, applyan og 0, ma NMOS 0, ma
Open, sir.
open. Thank you. So open. Okay. So humanatong analysis when input is 0. So try to observe. What is our output then? Is it VDD or ground? Asa na
VDD.
direct connection si output?
VDD, sir.
VDD. Okay? At least ma-observe ninyo, di ba? Na direct connection si output kay VDD. No? Di siya pwede makagid kay Shortman. So that's our conclusion. No? When input is 0, output is VDD. Or output is 1.
1.
So when input is 0, output is 1. Okay? Sige. Erase ako ng put. Balik ka itong drawing kanina. Pwede naman din balik. Erase lang ako ng mga kuan. Okay. This time, if our input is 1, so mo-split na siya, 1 ang ma-apply sa gate sa NMOS, sa PMOS, 1 po ma-apply sa gate sa NMOS. So if 1 ang PMOS, short. Okay? No, save. PMOS, pag 1, open. Open. Diba? So, open. Sa NMOS, if 1 ang gate, short. So what then now is our output? Asa na direct connection si output? 1 or 0?
0, sir.
0, diba? Siya direct connection sa output. So, when input is 1 sa truth table, output is 0. Okay? So, this is the simplest logic circuit or logical function that we could build using a pair of MOSes or a CMOS. So, yung pangalan ani na siya particular name, if you could observe sa truth table, bali, di ba? Kung unsang input, opposite ang output. So, we have a particular name for this one. We call this one an inverter. If positive 5 ang input, 0 ang output. If 0 ang input, positive 5 ang output. Inverter. Or, if logical names itong gamiton, this is called the NOT gate. Okay. Very simple circuit but very useful. All modern microprocessor circuits which make up our computer are made up of millions of these circuits. inverter or NOT gate. Now, sooner, if mag-analyze na to og mga higher level logic circuits, then medyo tedious gapon kung ano nga notation natin gamiton. So mag-apply na po ng abstraction. Ato siyang i-contain sa isa ka symbol or notation. No? Kung atong observe sa circuit, isa naman ang input, isa lang po ang output. So, may tabuan na ising ani. Okay? This is the input. This is the output. And the schematic symbol for a NOT gate is just an arrow with a bubble. So, kinsa diri sa inyo ang familiar na ani, NOT gate, or has encountered this one before? Logic circuits, digital circuits, NOT gates, AND gate or gate, or first time ni sa kadaghanan. Is this your first time, guys?
First time.
First time pa na ako niya, sir.
Sige.
First
Ito na,
time, sir.
no? That's good, no? So, kani, kung makakita ganit ani pohon, this is the NOT gate or this is the inverter. Meaning, again, for simplicity, if mag-apply tag 1 dire, the output is a 0. Diba? Say na kayo. Di na ta kinahanglan mag-map again sa sa circuit. No? Di na ta necessary nga inumduman pa kung sa itong buhaton sa PMOS ha, kung 0 or on or VDD, ana. So, yan nila ka-simple, no? Na somehow na-abstract niya, quote-unquote. Na-abstract na niya ang complexity. So, mag-apply tag 0 here. Simple ang output. Out this one. Yan na lang, no? So, that's how a NOT gate works or inverter works. So, before I proceed, any questions? If wala, we'll try to analyze another one. Sige. So, yun naman, di ba? So, sige, next na punta. So, how about this one? No? So, ako lang po i-redraw para sa yun. Be. So, yung sa taas. Mga PMOS sa taas, di ba? Mga PMOS. Okay, so notice ako mga slight modifications, no? It's conventional to draw the VDD as one singular bus, such as the one I've withdrawn, no? Pwede nga na. Pwede ganing ang ground is isa gyapon na siya ka bus. No? But since isa lang man ka drain ang nakakonect sa ground, ako lang as is. Ang kaning naka shaded na circle, that denotes a connection. Same here. Meaning kaning nga wire is connected sa kaning nga wire. Basta wala gani kuan, walay solid na circle. Meaning nga dili sa connected like this one. Sa una ginaani man nato, di ba? Gina-skip. Okay? Pwede lang ana, no? Wala kaso. Pwede lang gyapon ni ani. So this means dili na sila connected. Okay, wala may solid nga kuan, no? So convention naman na siya. Okay? This time, instead nga input-output ang gamiton, VA-VB man sa ano, sa given, I'll just simply use A and B para sa yon. And sa output, instead of V out, I'll use the letter Y. Mas conventional po ng letter Y. Okay? So observe kung parehara ba. No? Parehara. Si A, let's call this one Pmos 1. No? Di talibog. Pmos 1. Kani si Pmos 2. Kani si Nmos 1. Kani si Nmos 2. Pmos 1, Pmos 2, Nmos 1, Nmos 2, no? So, di maganda siya mag-matter, pero para dito malibog later. So, si gate ni Pmos 1 is connected kang A. Same din, no? Si gate ni Pmos 2 connected kang B. Si gate ni Nmos 1 connected kang A. Si gate ni Nmos 2 connected kang B. So, I think correct ang akong withdraw. Oh, I hope so. Wala na ako na later kung nabukoy sa iyo. Sige. So, we'll make a truth table. No? So, tungkol kaya nga itong inputs are A and B. So, A and B. Atong output, Y. Now, unlike earlier, na we only have two inputs, 0 and 1, who'd like to guess, class, how many possible inputs could we have for this particular circuit?
4, sir?
4. Thank you. Ano man?
Kuha lang, sir. Like,
Number
2
of
times 2 lang.
buses.
2 times 2. Usa man tong, sige daw, i-name daw ng upat ka possible inputs.
0, 0, 0,
Okay.
1,
Okay.
1, 1, o 1, 0.
Okay, thank you. That's correct. No? Very good. So for our possible inputs, it could either be both A and B are 0, both A and B could be 1, or A is 0 and B is 1, or A is 1 and B is 0. Okay, so thank you. Munang mga upat nato ka possible inputs. So mas conventional kung yani ang pag-state sa mga inputs 0, 0, 0, 1, 1, 0, 1, 1. Okay? So kang Y, nalagay na sa 0 or 1, no? Pwede, example lang, no? Example lang. Pwede 0, 0, 1, 1, and or 1, 1, 0, 0, or whatever, no? Okay. I think wala mo siguro na eh. So I'll try to map na our inputs and outputs.
Ayaw ba itong boba?
Sige. Sige, we'll apply 0 and 0 to both A and B. So 0 here and 0 here. Meaning, 0 po dire. Zero tanan. Sige, 0 diha, 0 dire, 0 kang PMOS 1, 0 kang PMOS 2. Muna siya. 0 pod kang NMOS 2. PMOS 1. On or off? Open or short? 1 or 0?
Short.
1.
Short or 1. Very good. Same kang PMOS 2. Kang NMOS, kung sa input, may output. Same here. So what is Y then?
1.
Asa na
One.
i-direct link si Y?
VDD.
VDD. No? Kaya if 0 si NMOS 1 and NMOS 2 is as if short ni dire. Short po na diya. So wala connection si Y si ground. So naalay direct nga route from Y to VDD either here or there. No? So na direct connection si Y kang VDD from both PMOSes. So when A and B are 0, Y is 1.
Ay, sir.
Yeah.
Connected din ang junction sa PMOS to, sir ba?
Kani connected din siya. Sorry. Kani?
Yes, sir.
Yeah, connected na siya. Yeah.
Ay, okay.
No, medyo libog yun kung dili tayo magamit itong ana, no? Sige, ako lang, maski ako nalibog ko, ako lang siguro na-replace.
Upay ang homemade. Ha? Homemade.
Ayan, siguro, no? Mas conventional. Next daw, be. 0-1, no? So, erase na ako ng mga kulis-kulis na to.
Ang dami nga flavor.
So, A is 0, but B is 1. So, asa ang mga 0? Suda una sa 1. Asa ang mga 1? 1 si NMOS 2. Or 1 ang gate ni NMOS 2. 1 ang gate ni PMOS 2.
Nawala mo lang.
But 0 ang gate ni PMOS 1. O kang NMOS 1. Before I go further, sakto lang akong pag-map sa mga inputs pa. No? Correct naman, no?
Yes, sir.
Okay. So, sugod ta kang PMOS 1. If gate is 0, state is 1. Kang NMOS 1 also, 1. Kang PMOS 2, when gate is 1, open. Same kang, save, sorry, save niyo. 0 na siya. Kani is 1. Check. Before ta mag-define sa output, i-check sa ako ang analysis. Sakto ra na? Basta PMOS ma-invert. Basta NMOS as is. Okay. So what is Y now? Asa na direct nga route si Y?
Sa VDD, sir.
BDD ba gyapon? Mo-agree mo guys?
Yes.
Okay.
Yes, sir.
Si NMOS 1 is off. PMOS 2 is also off. Okay, zero man siya. So even though walay direct connection si Y kang ground, namang gyapoy direct connection si Y kang VDD through PMOS 1. So yes, Y is 1. Okay. So Y is 1.
Bread.
So next, what if A now is 1 and B is 0? A is 1, B is 0. Ay, ano yun? So, kinsang na yung mga 1. Si NMOS 1 and PMOS 1. So, si NMOS 1 is 1, PMOS 1 is 1. PMOS 2 is 0, as is NMOS 2. Okay. So, NMOS 2, gate is 0, state is 0. PMOS 1, if 1 ang input, 0 ang output. Si PMOS 2, 0 ang input, 1 ang output. Si NMOS 1, 1 ang input, 1 ang output, as is. Okay. Sige. What's the output Y?
1, sir.
1 gyapon. Agree gyapon mo guys?
Yes, sir.
Yes, sir. Yes, sir.
Wala gyapon siya padlong sa ground no kay ang NMOS 2 is open man. Open man eh. Hmm. Pero pwede siya moagi dire. Adi siya kaagi dire kay 0 man si PMOS 1. Kang PMOS 2 na siya moagi. No? So na direct connection na si Y padlong kang VDD through PMOS 2. So yes, when A is 1, B is 0, Y is still 1. Last, when both of them are 1. So when A is 1, B is 1. If B is 1, NMOS 2 is 1, PMOS 2 is 1. 1 sa tanan. Okay. One tanan gate. One tanan input. So asa ang mga 0? Mga PMOS. So si PMOS 1, 0. Si PMOS 2, 0 gyapon, so open. NMOS 1 now is 1. NMOS 2 is 1. So clearly, there is direct connection from Y to
Ground.
ground. Okay. Hindi na siya kaagad eh. Okay, 0 naman si PMOS 2. Hindi na po siya kaagad eh. 0 po si PMOS 1. Matungod kay 1 na si NMOS 1 and NMOS 2, nanay direct connection from Y to ground. So, okay. When A is 1 and B is 1, Y is 0. So, how will we convert into words kani nga kuan. Kani nga truth table. Kinsay maka-guess, no? So wala gyud isa ka exact na statement nga maka summarize ani, pero depende sa tuwa, no? Depende sa pag-understand. How about you guys? How would you understand this one? Or how would you summarize our truth table using words?
If A and B is on, sir, are on, the output is off. Okay?
Okay, thank you. So, ito, no? It's as simple as that one. Y will only be off when both A and B are on. Ano lang. No? So, for this circuit, ito na pong i-abstract. No? The same yan eh. No? But karon, duha naman kabo atong input. No? So, duha atong input terminal. A and B. Ito output is isa ra Y. Conveniently, ingani ang itsura sa iyang schematic diagram. Marag spaceship. And ay bubble. No? So this is what we call a NAND gate. And, no? NAND gate. So NAND gate, or actually, if natay exposure before sa logic gates, namatay yung tawag na AND gate. No? This is an AND gate. So if an AND gate is followed by a NOT gate, so we have a NAND gate. No? Diba? Pero later na lang AND gate. So this somehow simplifies this operation or this logical function. No? So yun yung kailangan mag-map og CMOSes. Ano yun lang, if A is 0 and B is 0, based on truth table, Y is 1. Okay? Ano lang. If A is 0 and B is 1, Y is still 1. And so on and so forth. So this is the NAND gate or NAND operation. Sige, any more questions before I proceed? Nasa tanda ba?
Yan lang, sir.
Dahil naman, no? Ang nakasyadaan eh, walay formulas, walay equations. Subay-subay lang yun, og 1 og 0. So last circuit for this afternoon, well, for this semester, is this one. Sige daw. It's your turn. Dali naman eh, no? I guess this will only take you mga 10 minutes. Try to come up the truth table for this circuit. Sige daw, for the next 10 minutes. You could redraw this one using our shortcut for PMOS and NMOS ng mga symbols. So, makaya rin sa papel. Sige daw.
Sir, ang pa-inward, sir, kayo mo ng mga PMOS, sir ba?
Ang pa-inward is mga NMOS na sila.
Okay, sir.
So, I think mo ni ang mga NMOS. Sakto ko? Guys, no?
Yes, sir.
Mo ni ang mga NMOS. And mo ni ang mga PMOS. Yeah. So you're only going to produce the truth table for this one. A, B, Y. 0, 0, 0, 1, 1, 0, 1, 1. Wala lang. Sige, for the next 10 minutes. Okay, so nakuha na ninyo? Nakuha sa uban? So yes, if ang inputs are both 0, the output will be 1. And else, 0, 0, 0 na siya. Nasa ko siguro na. Okay, and ila pong determine yung name. And this is called an A NOR gate. Or not OR. Kailangan po tayo natawag nga OR gate. So yung schematic symbol sa logic design is ane A, B. Yeah. So kung ato i-summarize iyang function, the output will only be on or high if both inputs are off. Okay? So ito lang i-map ang isa, no? Just to illustrate or demonstrate. So if A is 0, B is 0, so 0 on the dire, 0 dire, 0 na, lahi na lang, no? 1, 0 na lang para na kalahian. So 1 here, 1 ni dire, 0, 0. So Pmos mo ni siya, so 0. Kani Pmos gyapon, so 1. Kani Nmos, so 0, Nmos 1. So open, short. So wala link from out to VDD. Kani short. No, open. Open dito. Kani open, kanyang short. So na-link from out to ground. So when A is 1, B is 0, V out is, or Y is 0. Diba? Okay? So is there any more questions on how we arrive to or at this table?
Sir, question lang sir, hypothetical.
Sige.
What if sir like nagya po na-apply ng example sir zeros on one sir, pero what if sir like nagya po path for both the VDD and ground sir, or like walay padunggan ang kwan, or like walay path padulong sir?
Actually, kisa ni siya, hindi na ako memorize ang voice, no?
Si Nico to sir.
Nico, sige. Nico, I don't think that's possible, no? Or that's why properly designed or designed as such ang mga CMOS circuits or digital circuits nga walay nga na nga possibility.
Okay sir. Thank you.
Actually, sige. Actually, naman, kanang finite naman ang number of logic gates po nga itong ma-design. So, far as I know, I think that ay 7. No? Na 7 ka logic gates. 3 of which, ato nang na-establish, NOT, NAND, and NOR. Naputay OR and AND, and XOR and XNOR. So, all of those circuits, walay possibility na ay direct link at one time sa VDD o sa ground. So it's either one or the other lagi na siya, no? At least we could confidently say nga wala nga na possibility. Okay?
Thank you sir.
Sige. So thank you also for that question. Any more questions before we end? Before we conclude our semester? Wala na? So if wala na, I've prepared an activity for you to do. Pwede nyo to practicean. No, dili. Katong activity nga akong gi-post. Graded to, no?
Sir, gi-post bago lang.
gi-post na, wag lang. Actually, ganyan pa lang ako gi-post before pa ng klase. Ansiran niyo to, okay? Pero mag-post po kog another set nga for practice purposes lang, ungraded. Para aside sa assignment, okay, dali naman to. Another set of circuits nga medyo more challenging for practice aside, no? Kapag second siguro ng activity akong i-post or exercise akong i-post sa e-learn, ungraded na to, no? Practice lang to siya. Okay?
Sige, sir.
Sige. So, if ano
Pwede ra man
questions,
ka ni sir i-paint ni guys. Ang gipangayo raman nimo sa mag sir kay
to
truth table.
stable. Pwede
sir.
ba? Oo.
Sige.
Kuan ganito, ang uban last time, ilang gigamit kay nag-Excel na to sila.
Hi. Gusto ko daw pa.
Pwede ba Excel, pwede ba Paint, or pwede ba good kinamot, good gani gyapon din. Picture lang. Okay?
Sige, sir. Thank you.
Okay,
Sige,
sir.
sige. So, again, reminder, the coverage for our final exam will be BJT amplifiers, FET amplifiers, and this one, CMOS circuits. And kana lang, theory and problem solving. Okay? So, see you all on, di na ito necessarily mag-see you all. Kay, di naman ta di naman ta mag-Google Meet. So, please do study, no? Study sufficiently, and may God bless your exams. So, di lang sa akong exam, but sa other subjects po ninyo. Sige? Bye-bye.
Salamat,
Bye,
sir.
sir.
Thank you, sir.
Salamat,
Bye.
sir.
Thank you, sir.
See you next
Thank you, sir.
see you next year and next sem.
Thank you,
LX2 na,
sir.
LX2.
Thank you, sir. Thank you, sir.
Next na lang.
Sige.
Bye, sir.